Hello, students. I hope your studies are going well. And today I am back after so many days with the new topic reversible equilibrium. So, in this topic, we are going to learn about what is reversible equilibrium, what is dynamic equilibrium, the factors affecting reversible reactions. Okay, so first we will learn what does this word reversible reaction mean. So we are having a normal reaction where there is a reactant and it gets converted to the product. And the second type of reaction is where the product can again form the reactant. So this is represented by a reversible sign. Okay, and the reaction can be made reversible by changing the reaction conditions. For example, temperature we can change. For example, we can change the pressure, concentration, etc. Here we are having one example of hydrated copper sulfate. Hydrated copper sulfate means it is having presence of water molecules. These water molecules are known as water of crystallization. Now, if I heat this hydrated copper sulfate, water molecules will be removed and it will change to a white color anhydrous powder, which is known as anhydrous copper sulfate. Okay, and water molecules are removed. Now, in this case, if I add water molecules back to that anhydrous copper sulfate, okay, it will again turn into the hydrated copper sulfate. Another similar example we are having is of cobalt chloride, which is pink in color. If I heat it, the water molecules associated with that crystal salt will be removed and it will turn into blue color. Again, if I add water to that blue color anhydrous cobalt chloride, it will again turn into the pink color cobalt chloride salt. Now, there are two types of system we are having. One is the closed system and another is the open system. Here in the diagram you can see the closed system where a reaction is being carried out, that is decomposition of calcium carbonate. So two products are formed, that is calcium oxide and carbon dioxide. In case of closed system, nothing can escape out of the system. So an equilibrium is formed in the system of the reactants and the products. Whereas in an open system, if you see, carbon dioxide, which is a gas, will escape and there are no chances of forming an equilibrium of the reactants and products. Chemical equilibrium. So chemical equilibrium is dynamic state in chemical reaction where the rate of forward reaction is equal to the rate of reverse reaction. This state is characterized by constant concentrations of reactants and product. In case of equilibrium, as we say, the word equi means something which is equal, which is same. So in this case, in reversible reactions, the rate of a forward reaction and the rate of a backward reactions are same. The concentration of the reactants and products are same. That is nothing but a reversible reaction or chemical equilibrium reactions. Now, features of chemical equilibrium. So here we are having concentration of reactants and products which remain constant. The speed of forward and backward reactions is also equal or same, and catalyst does not affect the position of equilibrium. So when we talk about reactions, catalyst also affect the reactions, but it will only affect the rate or the speed of the reaction and not the position of the equilibrium in reversible reactions. So, what factors are affecting the equilibrium? First factor which is responsible is concentration. Here I have written 2 points, that is, addition of reactants can increase yield and removal of products can increase the yield. Consider this 2SO2 plus O2 gives 2SO3 is a system. Okay, now if we talk about first point, addition of reactants can increase yield. So if I add more of oxygen or more of sulfur dioxide, they both will combine and form more of sulfur trioxide, the product. So yes, my yield will increase, my product will increase. Also, if I remove the sulfur trioxide from the system, the product side becomes empty. So to fill the product side, my sulfur dioxide and oxygen will react and again form sulfur trioxide. In this way, if I again remove sulfur trioxide, more of the product will be formed as the reactants will combine. So if I remove the product from the system to make new product, the reactants will combine and form new of the product. So hence my product yield will also increase. So if I add more reactants, they will combine to form the product, and if I remove the product, more reactants will combine to fill the empty space at the product side, and again my yield will increase. Second is temperature. So in case of temperature, we should understand that there are two type of reactions, that is exothermic reaction and endothermic reaction. Exo means exit and thermic means heat. So when the heat is released into the surroundings during the reaction, it is known as exothermic reaction. Endo means to take something in and thermic means heat. So when heat is taken into the system from the surroundings, it is known as an endothermic reaction. We know that in reversible reaction, there are two different types of reactions taking place at the same time. One is the forward reaction and the other is the backward or the reverse reaction. So here we are having this different chances. So if the forward reaction is exothermic, so definitely the backward would be endothermic. As I increase the temperature, as forward reaction is exothermic, it does not need heat. Instead, it will itself release the heat into the surrounding. So heat released by itself will increase the temperature. Also externally we are increasing the temperature, because of which there will be a sudden increase or sudden rise in the temperature. The heat will be then taken by the endothermic reaction, and hence backward reaction will be favored. So the backward reaction is from products to reactants. Here more of the product will break down to form new reactants. Okay, so anyway my yield is going to decrease here. Now here we are having this example, that is calcium carbonate giving calcium oxide plus carbon dioxide, or other example we are having is nitrogen plus hydrogen giving us ammonia. Okay, so in this example we can understand nitrogen and hydrogen combining to form ammonia. The forward reaction here is exothermic in nature. If I am increasing the temperature, it will favor the reverse reaction, which is endothermic. Now ammonia will break down to form nitrogen and hydrogen, and the position of equilibrium will shift towards left hand side. So here you can see this red color triangle, it is shifting towards the reactants. So more reactants will be produced and the yield of the product will decrease. Here we have another example of calcium carbonate, where the forward reaction is endothermic and the backward is exothermic. Okay, now when the forward reaction is endothermic, and if we are increasing the temperature, so by using the heat, the endothermic reaction will be favored and more of the products will be formed. So you can see the in this graph, the red color triangle is towards the product side on the right hand side. So equilibrium position shifts or favors the right hand side towards product side, so more of the product will be formed here. Okay, so when it is endothermic and the temperature is increased, more of the product will be formed, the yield will be increased, and vice versa. Third factor affecting is pressure. Now when we increase the pressure, it will favor to the side where there are few number of gas molecules, and when we are decreasing the pressure, it will favor the side where there are more number of gas molecules present. We will understand this by an example. Here we are having example of nitrogen plus hydrogen giving us ammonia. If we consider the stoichiometric coefficient written in front of the reactants, in front of nitrogen there is no coefficient written, so we consider it as 1. In front of hydrogen, the stoichiometric coefficient written is 3. So in total, on left hand side we are having 3 moles of hydrogen and 1 mole of nitrogen. So 3 plus 1 becomes 4. In case of ammonia, we are having the stoichiometric coefficient written, which is 2. So if we compare the left hand side and right hand side, we are having less molecules on the right hand side, on the product side. So if I am increasing the pressure, it will favor the side where there are few number of moles of gas. So definitely we are having less number of moles of gas on the product side. So hence my product yield will increase and the equilibrium position will shift towards the product side. Here if we consider the other reaction, that is sulfur dioxide plus oxygen giving us sulfur trioxide. Here also it is same. There are 2 moles of sulfur dioxide and 1 mole of oxygen. So in total we are having 2 plus 1, 3 moles of reactants, and on product side, on sulfur trioxide, we are having 2 moles of sulfur trioxide. Now if we compare, 2 is less than 3 moles of the reactants. That is why if I increase the pressure, it will favor to the side of product, that is on right hand side, and equilibrium position will shift towards the product side, hence my product yield will increase. In the same case, if I am decreasing the temperature, while decreasing the temperature, it favors the side where there are more number of gas molecules. So if I take the same reaction example, we are having 3 moles of reactants and 2 moles of product. So the reactant side is more. If I decrease the pressure, more of the reactant will be produced. So equilibrium position will shift towards the reactant side, and sulfur trioxide will break down to produce more of sulfur dioxide and oxygen molecules. In the third reaction, where hydrogen and iodine combines to form hydrogen iodide, we have 1 mole of hydrogen reacting with 1 mole of iodine to give 2 moles of hydrogen iodide. If we consider the reactant side, it is having 1 plus 1, that is 2 moles of reactants and 2 moles of product is formed. So in this case, both the moles are same. So even if we increase the pressure or we decrease the pressure, there would be no change in the position of equilibrium. Thank you. I hope you have understood this. Remaining Haber's process and sulfuric acid production, that is contact process, will be uploaded in another video.